So for any dilution calculation, so the clue is, seeing words like concentrated solution, dilute solution, working solution, stock solution, that kind of thing, you are going to use the formula M1V1 equals M2V2. Or alternatively, MI for initial, VI, MF for final, VF, or M conc, V conc, M dilute, V dilute. Okay, something like that. Okay, where this is coming from is we know that molarity is number of moles divided by volume. Okay, so we can rearrange that so number of moles is the subject. So N equals M times V. Okay, if you take that portion of moles, stick it in another container and like add more water to it, okay, so you still got the same number of moles, okay, and I've increased the volume of the water, so that's now new volume 2. The concentration is going to go down, so that's our molarity 2, okay, so it's the same number of moles, you've just diluted it into a larger volume, which means the concentration, so the number of moles per unit volume, has got to shrink. Okay, so it's kind of easier to sort of visualize this with like arrows, I guess. Like if this has gone up, then this must go down for the number of moles to be equal, which they know they are. Okay, so your dilute solution is always going to have a larger volume and a smaller concentration than your concentrated solution, the one that you start with, which is always going to have a smaller volume and a larger concentration. So you can kind of like visualize that kind of relationship, right? That the volume is smaller for this one and your concentration is bigger. Okay, so basically it's always going to be some kind of question of like, 3 things and you got to work out the 4th thing. The important thing is, I've said thing way too many times, of working out what is what. So a chemist makes 590 milliliters of barium acetate working solution, so that's going to be the dilute solution, okay, by adding distilled water to 220 milliliters of a 0.825 moles per liter stock solution. So these are going to be talking about your stock solution or your concentrated solution. Whatever is concentrated, stock, etc., is always going to be your initial conditions before you take it off and dilute it. So this 590 milliliters must be my final volume. So it should be bigger than my initial volume. So I can verify it is, look, bigger volume. So that is going to be my V2. So we are rearranging and solving for our final concentration, okay? So we can just make M2 the subject. So that is going to be M1 V1 divided by V2, okay? Now, units. If your concentrations and volumes are in the same units as each other, you don't have to worry about converting. I know we've got volume in milliliters and concentration in moles per liter. And ordinarily, if you were going to be mixing the two, right, in terms of a mathematical equation, like you'd have to convert milliliters into out. But if you look, volume is going to cancel with volume in this case, or if we were solving for volume, molarity is going to cancel with molarity. So we actually don't have to do that, provided that the concentrations and or volumes have been given to us in the same unit. So just watch for what you've been given in terms of units and what you are asked for. So my initial concentration is 0.825 molarity. I'll just write moles per liter because that's what it's done here. My initial volume is 220 milliliters, and I'm dividing that by V2, which is 590 milliliters. So look, see how the milliliters is going to cancel out, okay? So we're going to get our final answer in terms of moles per liter, which is going to be a concentration, which is what we're expecting because we are solving for the final concentration. Another thing that you should mentally check when you're done, you are supposed to be finding the concentration of a more dilute solution, therefore the concentration should be lower than for the stock solution. So I got 0.3076 blah 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 blah. We're asked for 3 significant digits, so that's good. 0.308 moles per liter. Is 0.308 less concentrated than 0.825? Yes, it is. So I can just verify that I have the correct answer there. Okay, so that was solving for our final concentration. So let's have a look. This time we're asked for the final volume. Okay, so let's do that then. Okay, so we have to dilute 80.2 milliliters of a 5.73 molarity aqueous solution until the concentration falls to 4 molarity. So that must be the final concentration. That means we had the initial concentration given to us here, and this is the initial volume. So we are asked to find the final volume. So we're going to rearrange M1 V1 equals M2 V2 and solve for our final volume, which will be V2. So that is going to be M1 V1 divided by M2. So mathematically, what we're doing there to rearrange that, if you're a bit like, oh, what's she done the math? We divided both sides by M2, okay? So on the right-hand side, the divide by M2 cancels out, okay? So you end up with M1 V1 over M2 on the left side. So let's stick some numbers then. So M1 is 5.73 molarity. V1 was 80.2 milliliters. And then our final concentration was 4.00 molarity. So look, the stock solution was more concentrated. 5.73 molarity is more concentrated. It's going to have a smaller volume, 80.2. My answer should be more than 80.2. If it's not, I've screwed something up. Okay, so 80.2, 5.73 times 80.2 divided by 4 gives me 114.88, blah, 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 blah. That's in milliliters. We're asked for how many sig figs now? 3 significant digits, so 115 milliliters will be my answer. Okay, so just make sure you can pick out the question, what is dilute, what is stock? You may even have some variations where you have to back calculate what the stock is, okay, or how much of the stock you need. So I'm just